for it. What up, dudes? What up, Algebra 2 class? We're getting ready to be started. Actually, we're getting started right now. What I'm going to do is I'm going to take this first 15 minutes of class to explain to you what our Algebra 2 final is all about. Here's the deal. Most people freak out when it comes to a math test. They think, oh, I can't stand the pressure of sitting there and taking a test right immediately. You know, I mean, like you need to just write down all of the stuff you know when you get the test. And so, in order to kind of curb that, I decided to do this first quarter's final in a little bit of different way. I decided to make it more of a like a project-based thing. And I assigned it on Friday, so you have like a full week to you had a full week and a half to take a look at it. Although I'm kind of going over the instructions right now, so you have about another week, and I think it's due on Thursday, so it's like a week and a day in order to work on this project. The project is 2 problems. That's it, just 2 problems. And today's class might be really crucial in kind of understanding those problems a little bit better. But at least watch the first 15 minutes of this video so you can understand what's going on. So, your final exam that you're going to be taking, I believe it's on Thursday, but don't quote me on that. We can check the calendar. Why don't we do that right now?
Wait, this week Thursday or next week?
No, next week Thursday. Yeah.
And the Friday is us recording like this, explain how.
No. That's all I'll do on Thursday. Okay. All right. This is chemistry. Here's my Algebra 2. Did I put my final? Okay, here we go. Okay, wait. I didn't put in when the final exam is. I think it's Thursday. All right? But anyway, your final exam is on Thursday, and I can double check that, and I'll email you if it's something different. And your final exam is going to come in 2 parts. The first part is kind of more of a computer-based exam that I'm going to open up on that day. It's going to be like 8 problems long, and it's going to be really straightforward. I'm not gonna. I decided I'm not gonna throw any curveballs at you. I'm not gonna make it super challenging or whatever. I just want to know that you understand lines and linear functions. And so all of that written part is only going to be on linear functions. In fact, if you look at, I gave you a practice exam, and that's this thing right here. Your exam is going to look almost I can't say identical, but it's going to look very similar to. I'll tell you what. On one of the problems, all I'm going to do is I'm going to switch up the numbers. All right? So, if you know how to do the practice exam, then the exam part will be really easy on Thursday next week. Sound good? It's taking a little bit of time to come up. Come on, hurry up. It's embarrassing. I've got my friends out here waiting for me.
Yeah, click on the title.
Oh, okay. Does it go faster then?
Yeah, it just takes you to a new tab. Sometimes it has to open in a new tab too.
Yeah.
Mine never opens in that kind of.
In the little box?
Yeah.
Come on, buddy. It's right here. Here we go. Oh, there we go. Awesome. Your written part of your final is going to be very similar to that. This is like 9 questions long or 10 questions long. So your one is gonna be something like that. I'll most likely give you a problem that's very similar to each of these problems over here. Cool? Nothing I think that is too crazy. I think maybe the craziest thing that I might get into is I might tell you, okay, where do these 2 lines cross if this line is perpendicular to this other line or something like that? That might be a good question, right? And that might be the craziest thing I might do, where I won't actually give you the actual line. I might just tell you, oh, it's perpendicular to this line, and it goes through this point over here, and then you got to come up with the equation for the line, and then you guys got to figure out where they cross and all of that kind of stuff. You guys kind of vaguely remember that stuff?
Yeah.
Yeah. All right. So it's not so bad. The second part of the test is that one is going to be more of that's called a performance task. And those are more of this is more of the project-based kinds of things. And all of that stuff has to do with parabolas. All parabolas. the first parabola. Oh wait, let's just click on the thing because, like you guys said, it goes slow. Oh, it came up and then it. All right, whatever. All right. All right. This is your project-based midterm. It has two parts to it. The first part is basically I've been trying to learn how to play basketball because they've been asking me to play basketball with them. So I read a book on trajectories and physics, and I was learned how to shoot a basketball. That's a total lie. I'm a complete klutz when it comes to playing any kind of sports and whatnot, and I'm very asthmatic. I'm the classic stereotypical science nerd. So, you know, I mean, I really, hey guys, wait up. And then I get my inhaler out and I'm just like, wait, hold on, you guys. And I need to breathe my inhaler and all that kind of stuff. And I play trombone and, you know, I'm in a band geek as well. So very stereotypical classic nerd, socially awkward, the whole 9 yards. That's me. So that basketball video actually it only took me 3 minutes. I just kind of kept throwing basketballs behind my head until I got it. But the arc that it makes is a parabola. And we can apply our math equations to the parabola. Is anyone else having trouble with the audio? Check. Audio check. Okay. Can someone type to Bianca and let her know that she might need to log out and log back in? Okay. So, what I did was let me see if I can pull up the old files. And this might take a little bit of time. Did everyone see that video? Because I thought it was the coolest thing.
Yeah.
You did? Yeah, I was like, yes!
My friends and I go to basketball court on Sundays and we just shoot hoops and stuff. And sometimes we do this thing called a granny shot where we just go like, with the ball.
Yeah.
Completely ignoring all the rules of basketball, like just the way you're supposed to throw it and everything. We just go.
Yeah, go do the under. Is it the under your legs kind of shot? Yeah.
And we made it a couple times.
Actually, that's
just nothing but net granny shot. Like, yeah.
I always thought that was the easier way. All right, here we go. So I'll show you the video, and then I'll show you guys the file that I use. So here's the video.
Yeah, they're playing basketball right now.
I have
Physics.
Yeah. Yeah. Sorry, it's physics. Physics. Yeah, I know it's lagging, but I put a YouTube video up so you guys can watch it. So it's up there. You guys don't need to really see the video for that. It's on the thing. Trust me. I've put it up many times, and you can watch it as many times as you want because I've watched it like 6 times already. All right. The second thing I did was I took a program called Tracker. And you guys, if you guys can download this on your computers, although I don't think it downloads on top of the Chromebooks, but you can download it on any Mac or PC that you have at home, and it's a free program, and it's really cool. In fact, if you guys study physics with me, which I would highly recommend it because I really like hanging out with you guys, then you guys will probably be using this program more and more. But let me show you what Tracker does, and I'll kind of show you kind of the idea behind this project, because this is the part of where I actually did need a video to explain it to you. Okay, so let's open up a recent file. We'll call it Basketball Math Inverted, the Tracker. What? No.
Tracker was hard.
All right, here we go. It doesn't have my file anymore. That's not good. Okay. User. Oh, it's because I took it and I put it on a different thing. Okay, wait. Let me see what's going on. Okay. That's my baby, by the way. All right, let's see. Snag it. Basketball math. I think it's because I moved the thing and it doesn't like that. Wait. I got to show you this because this is important. Okay. Now, can you find it? I put it in the same place. It's got to restart the whole thing. The program's up here, right? Whatever. Whatever, dudes. Let's do it. Did it not do it? I should have. I don't know what happened. Okay. All right. Let me show you kind of what's up, all right, folks? And this might take a little bit longer than I had suspected, which is a real bummer because I want to do this real quick. All right. What I did, I want to find it on my desktop. I got to redo this, so I'll show you guys my tracker real quick. What I did was I reset and made a new X and Y axis. And this X and Y axis is a little bit weird because people mainly are used to seeing the X and Y axis as to be exactly at, on the bottom left-hand corner, right? That's where you guys are used to seeing the origin at. You guys are used to seeing the axis to be right here, right? But this time, I made it a little bit funky.
Yeah, because the axis.
And I put the axis right there. The reason being is because, all right, what's nice about this tracker is I can scroll through frame by frame. The reason being is because, there we go. If I scroll back, see the ball's up in the air. Can you guys see it? It's right there. You guys see it?
Yeah.
All right. The reason why I made this thing right there, actually I should probably pull this axis back a little bit like this to be right about here. I think this is where I made it, right there. This is my y-axis and this is my x-axis. Got it? The reason why I made it is because I wanted to make it to be at the exact same height as the hoop. So I actually raised my axis 10 feet off the ground, off the floor. So when you look at the arc, which kind of goes like this is your parabola, you have two x-intercepts. The reason why I had to raise it off the ground is because if I didn't, then you wouldn't have two x-intercepts, right? Because the ball would hit the hoop and then it would get all messed up and it wouldn't look like a nice arc anymore. So I put it up high so you have two nice x-intercepts. And so I gave you the x-intercepts. I told you what they were. Apparently, they are, apparently those two x-intercepts are, where is it? Oh, 1.4 seconds and 0.3 seconds. By the way, your horizontal axis is not x, it's t. Because we're measuring the height versus time. That might freak you out because all we've been doing is things with x. But you just change x for t and it's all the same stuff. So your standard equation is going to be like at squared plus bt plus c. As opposed to ax squared plus bx plus c. Got it? That's all we're doing. So don't freak out when it comes to switching those two things out. Cool?
I'm more freaked out about the elevated x-axis.
Yes, the elevated x-axis. By the way, maybe, well, since the elevated x-axis, it is kind of freaky, but see this point right here?
Yeah.
That would be your, do you guys know?
Y-intercept.
Your y-intercept.
That would just be where you...
So your y-intercept happens to be below the, where you call the 0.
Yeah.
Right? Oh, oops, I think I gave you guys some answers to this thing already. Sorry, my bad. All right. Question.
I might have missed this because I was in the restroom, but so above your head basically is where 0 is?
The 0 is actually right here. This is 0y and 0x.
Okay.
Usually you're used to seeing it way down here, but I raised it up higher because then the ball will cross the x-axis twice.
So, but we've seen problems like that, like if the parabola was like on the complete lower
Yeah,
side. It would be
yeah.
okay.
Yeah, we've seen problems like this. This is this is a problem we have, we've totally seen before. And I'll tell you what, today's lecture will probably help you out with this problem because we're going to be doing the quadratic equation as well. You guys got it?
Yeah.
All right. I don't really think that there's any other complications to this problem.
Except for question 12.
All right. What is question 12? What was the problem with it?
It was something about A and like.
Oh, okay. All right, referring back to your, I see what it means. Look up the value in SI units. If you don't know what it looks like, referring back to the standard parabola, take your value of A. Compare this number to gravity, to the value of gravity that you looked up.
Terminal velocity.
No. I'll tell you what, today's lecture will probably kind of explain that concept a little bit better. I'll make sure to go into that. All right, so that's that problem. The second problem is very simple. It's basically how much would you pay for something? And guess what? The reason why I wanted to do this exam is because I want to show you folks that math is not just crazy stuff that I make you do. It's actually applicable to your lives. Now, most of you are saying, well, yeah, but you don't do all of those calculations to shoot hoops. You just shoot hoops, right? Yes, that's true, but check this example out. This actually has relevancy to you if you're going to go into business. And, money's important. It's not always a good thing, but it's important, definitely, for sure. And so this problem kind of goes into that. There was one part that I didn't teach you how to do yet, and that's how to match a parabola to 3 random points. And I remember looking in your notes, and Acacia had in her notes, like a class she took last year, and she was like, matching a parabola to 3 random points is hell. And it is. It's actually not that easy. I'll make sure to teach it to you guys soon, but I haven't taught it to you yet. So I devised a really clever way of giving you guys, or making it easier for you. Okay? Here's how you do it. You open up this spreadsheet. In the problem, okay, wait, is this done loading? Oh, where's my graph? Oh, wait, it's still working. Whew, I was wondering where my graph was. There we go. In the problem, they gave you 3 points, the blue points, 1, 2, 3. We need to match our graph so the red parabola, do you see the parabola? The red parabola matches this blue graph. Let me kind of help you out here. What do you think the A is? Is it a positive or negative number? No, I think it's -1 if I have to have a parabola that matches those 3 points. You guys see it?
Yeah.
So we'll just make it -2 or something like that. All right, so that's that's how our graph now looks. Then what do we need to do? We probably need to raise this thing up.
Wait, did the 3 points change or?
No, the 3 points didn't change. They're still
Oh,
there.
it's just that the graph is different. Okay.
Yeah, the graph looks a little different. So let's raise it up. It looks like back when that was 1, that this parabola peaks out at about what? 73 maybe? So let's try pushing this parabola up by 73. That would be changing the k value, right? So I'll plug in 73. Oh, and I still need to make it -1, right? Or negative.
Yeah, negative.
I also need to pull this thing over to the right. So maybe we'll make it like 5 or something like that. So now it's kind of close, but you have to tweak the numbers to get them as accurate as possible. Got it?
So you have to play with the spreadsheet.
So you play with these 3 numbers in the spreadsheet, and that will give you your A, H, and K values in the vertex form, and voila, we now have a parabola.
Okay.
And we've matched it to the things. This is the much easier version of solving for a parabola with 3 parameters that we would need to match. If I didn't teach you this, I would have to teach you how to do row reduction echelon form in matrix operations. Don't worry, we'll get there. Not yet. I decided not to throw that little gem at you for your midterm exam. I'm sure that would freak you out. All right? So play with these numbers until you can get them to match the blue numbers nicely. And that immediately gives you the vertex form of your parabola. Then you can mess with that and figure out all of the different answers that I asked for. All right. What you're probably going to be asked to do, and I realized I didn't look at any of the comments that you guys were making because I didn't have that window up. But what you're going to be asked to do is record a video of you guys coming up with the solution. You can type it up. You can make a presentation. What I would do is the easiest thing, personally. I would write it all down on a piece of paper and then just like have the video camera looking at me and then say, look at this equation. This is what I did to solve it. And then I would point to it. I would kind of look like, okay, wait, where's my video camera? Okay. I would just like take a piece of paper and say, look at the paper, and then here's the equation, and this is what I did, and this is what I did, and this is what I did. Thank you for watching. Something like that. Make sense?
Yeah.
So
Question.
the reason why the axis for the basketball is pushed up is because the basketball tends to bounce.
No. The reason why I have the basketball pushed up, by the way, you guys can switch over to the camera mode. Or you know what, I'm just going to force you guys all to switch over to the camera mode. Webcam meeting. There we go. Camera mode. All right. The reason why the basketball one is pushed up is because here's me. Here's the basketball hoop. Got it? And here's the arc. Can you guys see that? Maybe turn on the lights because it's hard to see on that. Is that better? Can you guys see better now? All right, here's the axis, and here's the arc. Looks something like that. Okay? The reason why I pushed it up is because if I had it down here, or because I wanted to give you 2 x-intercepts. Right here and right here. Apparently, if this is the time axis, this happens at 0.3 seconds, this happens at 1.4 seconds. Got it? If I had it down here, this ball would come over here and then it would kind of mess around and it wouldn't give me a nice 2 points that it goes to. From these 2 points, and also knowing one other piece of information which you have to figure out how to get. From the 2 points and that other piece of information which I give to you, you have to tell me everything you know about this parabola. You can have it in the factored form, then you turn it into the vertex form, then you turn it into the standard form, and then you basically tell me what the x-intercepts are and how high this thing goes, and all of the information that you can gather just from knowing these 2 points. I think that's awesome. I think that's kind of what the point of math is. So any questions about the final exam? Because we are done talking about that. We're going to move on to actually talking about some algebra.
So the first problem has 4 parts, and the second problem has 4 parts?
Yeah, basically. The first problem has about 4 parts. I think this, to be honest with you, I think the second problem is a little bit easier than the first one. I think that, what else do I know? I think that don't spend all of your time making those dots match up perfectly. I actually made them, a little bit harder decimal. I didn't just choose like nice numbers. I made them harder decimals so that maybe you don't get them perfectly, but that's fine. Just take the answers that you get, that after you're satisfied with, it pretty much goes through these 3 points. After you're satisfied with that, use those answers and just calculate the rest of them. I'll take into account the error that you made back here, and I won't perpetuate it through the thing. If you make a mistake over here, and then but you do all the right steps, even though your answer is going to be wrong because you chose wrong numbers here, I won't burn you on the second half of the problem that you did. Does that make sense? All right. Questions, comments, concerns, vomits, etc.
So there's some questions with the 3-point thing, the 3-point thing with the parabola. We should try to practice doing that.
No. Occasion's asking, okay. In order to have a parabola, you need 3 points at least. A lot of times we give you the 2 x points, right here and right here, right? And sometimes, then we need to at least give you a 3rd point. If we give you a 3rd point, usually what we use is like the y-intercept. Let's say this is the y-intercept. That tells me my parabola looks like this. Does that make sense?
Yeah.
Because if I didn't give you a 3rd point and I only gave you 2 points, you could draw any amount of parabolas, or a really fat parabola, or something like that.
Yeah.
So you need a 3rd point to kind of control what your parabola looks like.
And so you can solve for
It's kind of like going back to the thing where I said, draw me a line that goes through this point. And you'll be like, I can draw you infinitely many of lines that go through that point. Are you kidding me? There's one here, there's one here, there's one here, there's one here, right? So you need how many points to describe a line? You need at least 2 points. Now, draw me a line that goes through these 2 points. There's only one line to draw. Boom. That's it. Can't draw me that one. Can't draw me this one. Has to be that one. The parabola needs 3 points. Now, here's the part that's a little bit confusing. For that second problem, in all the problems, I've always given you points, the 2 x points, this point and this point.
You should tell that girl about the final.
What is that?
Not a girl.
Oh, yeah, no, sorry. We're talking about the final exam. You can watch the video to catch up on where we're at. But that second problem, on all the other problems, I've always given you 2 x points. And so those 2 points are at the same exact height, right? For this one, for the second problem, I give you 3 points. I still give you your 3 points. But I think the 3 points are like here, here, and here.
Oh, so it's just
Now there still is only one parabola that will go through it. It happens to look kind of like maybe this. Or something like that. But that one is actually a lot harder to do. You can't use the techniques that we've learned so far to get the equation for this parabola.
you have to just kind of guess and check on the spreadsheet.
What the only way to do this, there's 2 ways to do this. One way is if I teach you how to row reduce a matrix, which sounds crazy and is actually kind of what your teacher tried teaching you.
Oh,
I don't
okay.
think it was very successful.
Yeah.
It sounds crazy, and it is not as bad, but I just haven't taught it to you yet. Or the other way is to guess and check. And to guess and check is to make a spreadsheet and just check it out, see which parabola can match these 3 points. So I gave you guys the second route, and all you guys got to do is just play with the numbers till it matches. Sound good?
Yeah.
All right.
So many times as you get close to it.
Yeah. Just tweak it a little bit, and then say, it doesn't match up. I'm going to change the k value, which does what to a parabola? The k value
H.
pushes it up. Then the h value moves it right and left. In the equation, I already built in that negative, so if you put a positive h value, it will move it right. If you put a negative h value, it moves it left. Even though normally moving right and left is a little bit funky, which we've discussed as well.
You formatted everything.
I formatted it all for you.
I'm really bad at doing stuff like that.
Yeah, no, I did the work for you for the spreadsheet.
Thank you.
Yes, I figured that I could just tell you, use a spreadsheet and then let you go from there, but I figured I'd help you out a little bit. I don't want you freaking out about those kinds of things. I want you guys, if you guys have trouble, I want you to have trouble on the math, not the computer part. All right, questions. So we were talking about the midterm exam, but won't midterms be in December because, of course, sheet says, of course, ends in July, not December. Okay, I see. Algebra. Oh, hey, by the way, we're all done with talking about midterm. I think you can go if you want. You look like you're zoning out. So, hey, Andrew, take care, man. All right. Algebra 2 is a year-long class, but I think we have. It's basically 2 classes, each lasting a semester, so 2 quarters. So technically, your final exam for quarter 1 is really just a midterm. And then your final exam for in December, the one we have, that's an actual final exam that will take care of Algebra 2A.
So do we actually come to the school for the end of course exams?
I don't think we've decided that. In the past, we have made people come in and actually take a written test. I don't know yet. I haven't decided
Well,
that.
if we do, could we bring notebooks and stuff?
That also I haven't decided whether or not it's an open note test.
Then it's hard to memorize all the formulas.
My personal suggestion would be anytime a professor asks if you want to take an open book test, say no. I'm just letting you know. Because the reason why, and I'm telling you this coming from the point of a professor. I've taught at community college, I've taught at university, and I've taught for like a long time at high school, is that when people ask for open book tests, then I think to myself, oh, I can make this as hard as I want then. And I make it super hard because you should have, because you guys have a big crutch of bringing in your book. But if I don't make it open book test, then I think, well, I don't want to make it too hard. I'll do that. So that's kind of my mentality. And every single time I've taken a class and the teacher had an open book test, it's super hard. They just make it like ridiculously hard because they're like, all the students get the books. They get whatever books they want, whatever, So then they kill you.
Yeah, because normally, like, for our past, like, final exams, we just done it on the computer.
Yeah. So we'll decide. We'll see that. We'll get to that when we get there.
Yeah.
And by the way,
I don't see if you're just changing
I'm not always going to be giving you an exam that's more of a project. I'm going to go back to those traditional styles. I just want to do this first quarter something different for you. All right? I don't know. Maybe you might like it better. Maybe you guys might hate it more. I don't know. So next quarter, I'm just letting you know, quarter 2 is probably going to be more of the traditional exam that you have to take regular style. We cool? All right. Quadratic equation. You guys all saw me derive the quadratic equation, right?
Yeah.
Do you remember it? Acacia, you got it?
Negative b plus or minus.
Well, okay, wait. Tell me the story.
I think I forgot a part of the story because I was trying to think of this last night.
Okay, all right. Tell me all the parts of the story you can remember, and then you guys can fill in any gaps that she might have.
So there's a negative boy
Negative boy.
who is uncertain about whether or not he wants to go to a radical party.
Okay, wait, 1 second. I'm sorry. I don't mean to cut you off. It's just they're asking questions, and I didn't get to them. It's hard to see this thing. So we're going to take 2 final exams, one in December and one in July. Yes, Bianca, yes, you are taking 2 final exams. Algebra comes in 2 parts, 2A and 2B. 2A, you have a final exam for. That's in December. 2B, you have a final exam for. That's in July. Got it?
Wait, July?
Oh, it's in May. Not July. No. Whew. Unless you're taking summer school with me.
No thanks. You're fun, but.
Yeah. All right. Okay.
All right. So
Negative
back
boy.
to the negative boy who's unsure if
Unsure.
he wants to go to the radical party.
Radical party. Good.
I feel like this is the part where I missed out on something, but I think that
You remember the 4 awesome chicks, but
Yes.
that's before that.
he's
he
not
was
cool.
he was not cool, and so they
So
called
he
him
can't.
a
Square.
square. He was being a
That's what
square,
it is.
right?
They call him a square.
In the movie Pulp Fiction, she goes, "Stop being such a square." Although I wouldn't recommend watching Pulp Fiction just to get that reference because that's not it's a rated R movie. But I liked the movie when I was a kid. Yeah. So he was a square.
He was a square, and because of that, he missed out on him.
Yeah, and he remembers the 4 awesome chicks. He was like, I got the 4 awesome chicks. Chicks are cool. And then the whole party was over.
2 a.m.
Good, you got the whole thing. It's a negative boy, unsure, radical party. b squared minus 4ac all over 2am. Now please don't just remember the story, actually remember how the story relates to the thing. Because there'd be no point in you remembering the story and just be like, you'd be on an exam and just be like, well, I don't know the equation, but I can tell you something about 4 awesome chicks.
Yeah, here we go.
Yeah, let me
Get
tell
ready
you the
for a
story. Right? No, don't do that. All right. Equals x. So here's how you use it. Here's how you apply it. You see if an equation is of this form. Ax squared plus bx plus c equals to 0. Got it? Ax squared plus bx plus c equals to 0. I hope you guys can see that. If you guys can't see that online, let me know. I'll try using a different pen. And then what you do is, it has to equal 0. All right? If it doesn't equal 0, then you need to change, then you need to make it equal to 0. The right-hand side has to be 0. You have the standard form equals to 0. That's the only way it works.
Yeah, because there's a problem in the homework where we have to set x equal to like 40 or something, and then I manipulated the equation to get 40 on the side with c.
Yeah, exactly. So
And
so for example, let's just make up a problem. How's about negative 16x squared plus 60x plus 2 equals 7. Actually, let's not make it 7. Let's make it 10.
yeah, because I think the problem was you're trying to find.
So here's the thing. This is not equal to 0. Right? It's equal to 10. How do I make it equal to 0? Minus 10 for both sides. Now, I'm minusing 10 only to this 2. Because you don't want to combine unlike terms. And the 10 is only like the 2, but it's not like x squared or the x. Right? So really this becomes negative 16x squared plus 60x minus 8 equals 0. Now you can apply the quadratic equation. And it's very simple to apply the quadratic equation. The only other complicated part about what I'm going to cover today is I feel like you guys know how to write down an answer, and I bet you guys are going to screw up putting it in your calculators. That's the only other part that's hard. Messing up putting it in your calculators. I bet you 1 or 2 of you are going to screw that up. I'm just letting you know ahead of time. All right. Apply the quadratic equation. Tell me what the A is.
Quadratic equation get you. Right?
Okay, good. I love that question. I love that question. Bradley's asking, what does the quadratic equation tell you in the first place? This is usually equal to f of x, not 0. This is usually equal to y. But we set it equal to 0. Whenever we set the y equal to 0, what is it getting us? The x-intercepts. Where the thing crosses the x-axis. Exactly. So it's getting you your x-intercepts. Because this is saying x-intercepts is at this point. And actually, even though this looks like there's one answer, there's actually 2 right here. Because you take the plus version, and you figure out what that answer is. And then you take the minus version, and you figure out what that answer is. Which makes sense because our parabolas, if they cross the x-axis, usually they cross at 2 points.
So that means you're solving 2 equations, but is that essentially what you're doing?
No, we're not solving 3 equations.
Or 2?
Yeah, 2. This is actually 2
Okay.
equations.
Gotcha.
After you get numbers, they become pretty easy to plug in. You just got to figure out how to do it correctly. All right. Let's try this problem. Because I think it's very similar to the one on your homework. All right, cool. What's your A?
Negative 16.
Negative 16. What's your B? 60. What's your C?
Negative 8.
Negative 8. Because it's A plus B plus C, so that negative 8 is actually, you can think of it as plus negative 8. That'd be cool. Bianca's asking, so the b squared minus 4ac, do we do that all together, or do we solve the 4ac first?
Oh, yeah,
Um,
that was another-
I would recommend maybe doing things separately first before you plug it all together. So I wouldn't mind doing the 4ac first, because a lot of times people screw up the b squared minus 4ac. When in doubt, just follow the PEMDAS rule, and that should get you to your right answer.
Don't forget it can change.
Got it? All right. So all you do is you take these numbers and you plug it into the quadratic equation. So this becomes negative 60 plus or minus, oh, no, oops, yeah. It's negative 60 because b is 60. Plus or minus the square root, oh gosh, 3,600.
Big numbers
Yeah.
are fun.
Big numbers are scary. Use calculators in quadratic equations. Minus 4 times 16 times 8.
Negative 16, negative 8.
Aha! Negative 16, negative 8. But I did that part in my head. I mean, maybe you guys might be more careful. I don't mind. But a negative 16 times negative 8 gives me a positive. So I didn't really worry about that.
And then do you multiply that by positive 4 or negative 4? Like, do you multiply by positive 4 and then subtract it from 3,600, or multiply by negative
Yeah,
4?
this part will screw up a lot of people. So I'll tell you what, why don't I not do it in my head and I'll just do this. Negative 16 times negative 8. And then what we have is this negative times that negative makes it a positive. Then you want to do, I would multiply that number by 4 and subtract that answer from 3,600.
Oh, wait.
Yo, question.
No, I'm just gonna try to process what you just said.
Okay, yeah. You want me to be like, dude, hold off a bit. Can you guys see that online? Can you see what I wrote? No? Well, that sucks. Let me try it again. Oops, I turned off my microphone. No, I don't want that one. Why am I screwing this up? Oh, I forgot to record the meeting.
The whole thing.
No, I'm recording the audio. I'm recording on YouTube, but I'm not recording. How's that? Is that better? Okay, good. I need to plug in. All right. So let's do this. By the way, what's 4 times 16 times 8?
512 negative 512. No, that might be right.
Whoa. TV?
Five negative.
No. Use a calculator. 512?
Yeah, negative 512.
Okay.
Yay, they're all in my head.
All right. You're amazing.
I give you props. I'm not even attempting.
All right. So this is. Oh, I'm sorry. Divided by. I forgot to do this part. Divided by 2 times this number.
Negative 32.
So that would be negative 32 on the bottom. So this is negative 60 plus or minus the square root of 3,600 minus 512. Okay?
All over negative.
All over negative 32. should probably just plug it straight in. Thanks, Eleanor. All right. And then, what's 3,600 minus 512?
3,088.
Yeah, just plug it in here.
Yeah,
3,088.
I think, yeah. Oh, wait.
Cool, thanks. What is it? 3.
Yeah, 3,088.
All right. Yeah, I agree. Negative 60 plus or minus the square root of 388 or 3088. All right, Mr. Calculator. What's the square root of 3,080 or 3,088?
Don't do it.
No, no, totally calculator. If you did that in your mind, I'd be impressed.
It's irrational. 55.56.
All right, so it's negative 60 plus or minus the square root, or 55.
55.569777.
Let's go 5.7. How's that?
Oh yeah,
Divided by negative 32.
that's a question I had. I forgot what it's called. Rounding.
How many
should we
significant
round?
figures? What do you round off to?
Yeah. What's best for our test?
In math, math is not like chemistry. In chemistry, I make a big deal out of it. You folks who take chemistry from me know that I'm like a jerk when it comes to significant figures. In math, I'll just take 2.
Okay.
2 places after the decimal place, I'd be pretty happy.
Cool.
Got it? Yeah, the 100th place. All right. So, really, this means 2 separate things. This means negative 60 plus 55.57 over negative 32. And this means negative 60 minus 55.57 over negative 32. Got it?
Yeah.
What is this? Use a calculator.
What are we looking at?
What is negative 60 plus 55.57?
Oh, I'll let him do it.
Close that parentheses, and then divide by negative 32. So it's like 4, it's almost like 5 divided by 32, which would be, I don't know.
I got negative 3.61. I don't know if I didn't even the right stuff, but that's what I got.
You got negative 3.61 for this?
Yeah.
0.13.
No, maybe.
I think it's more of a point. I would say, I would agree with you.
I think it should be a positive number. You're
Yeah,
subtracting
it is
a
a
larger-
positive.
It's what?
It's
0.138?
0.138. And then all of the.
All right. What about this number right here?
Oh, yeah. I see what I did.
That's positive.
That is a positive one too. Here's where I'm saying you guys will screw up your things. By the way, Bianca, I'm sorry. I'm so sorry. I'm trying to. It's hard for me to see the computer screen. So let me read back. Oh, okay. Yeah, Bianca, I'm glad that Diane was able to answer you. The reason why I made it equal to, I've had a negative 8 is because the equation has to have your standard form equal to 0. It can't equal to 10. All right, by the way, what is this answer?
My calculator's broken.
3.611.
3.611?
Which rounds it off to 3.612.
Yeah, 3.61. To the 100th place. Okay. A lot of times people screw this up when they put into the calculators because they forget to put maybe a parentheses around the top over here. A lot of times they'll put negative 60 minus 55.57 divided by negative 32, and what their calculator will think is that their calculator will think, oh, so you want me to do this. and you say no, that's going to give you the totally wrong answer. So what I like to do is I like to put a parentheses around this first part, and then type the divide by 32, or divide by negative 32. That's what will give you the better answer. That will actually give you the right answer. Okay? So learn how to use your calculator correctly. All right. So we did the quadratic equation. Is it hard?
No.
Is there a lot of steps?
Just the
You
old
just,
form.
you just need to write down.
I have a feeling that might throw me off, but I'll keep practicing.
You just got to practice it.
Yeah.
Just plug it in, chug it out. Make
That
sure you
part-
learn how to use your calculator good.
Yeah.
That's really it.
That first part is not.
So the quadratic equation is not hard. It's long. There was a lot of steps. Not that bad. Just tedious. Remember I said it's kind of like your bazooka.
Oh, yeah.
It works. It will kill the fly in the room. I guarantee it. So that's is wondering what the heck I'm talking about. I said, here's what I'm saying is, when I look at a quadratic or when I look at a parabola, you know, like this. When I look at something like this, I think to myself, there's a few ways I can solve this. One is to use factoring, right? That's a nice, clean, elegant way. Boom, done. The problem with that is that it only works if the numbers come out pretty.
Yeah, so how can you tell which finding the x way you could use?
I love that question. Let me get back to that. But it only, but
Will be easy
but
to
factoring
use.
only works if the numbers come out pretty, right?
Mhm.
The next thing you could do is you could try completing the square. Kind of a pain in the butt, right? But it works. It doesn't matter if the numbers are pretty. It will work. So I call it my bazooka or a hand grenade. Because if I want to kill a fly, I could use my fly swatter, which is the factoring. It's nice, quick, sweet, or I could use a hand grenade. Both of them work. One is a pain in the butt to use, probably a pain in the butt to clean up, but it will work. Got it?
Yeah.
The third option is to use the quadratic equation. But really, using the quadratic equation is just completing the square, just in a kind of a package deal. You got to remember the equation, right?
Yeah.
So, I mean, quadratic equation, all it is it's completing the square for you. Okay. So, let me talk a little bit more about parts of this quadratic equation, and then I'll go answer your question, because you're asking a good question. All right. Check this out. If I were to change these x's to t's, and I put a little tail on my t like that because I don't want my t to look like this, then it just looks like a plus sign. If you're wondering why I write funky t's. Then this is describing a parabola that looks kind of like this. Like this problem right here would be a parabola that kind of looks like that. Got it? Obviously, it's upside down, right? And it's maybe scrunched up a little bit. And I'll tell you, what is the y-intercept of this parabola?
Moves it up. Oh,
This one right here. What's the y-intercept?
2.
If I made this f of x, then it's 2, right?
Yeah.
What this is telling you is that this is a parabola where it starts off 2 feet above the ground. And then it's kind of like, I look at this as like a baseball player. A baseball player hits the ball, boom. It's about 2 feet off the ground, that's where it starts. This number right here is associated with the velocity of the ball, the speed of the ball. This number right here, well, I'll show you where it comes from. It's actually pretty cool. When I set this thing equal to 10, what I was doing really was I was saying, at what times was this ball 10 feet off the ground? And apparently it was 10 feet off the ground at 0.13 seconds and 3.61 seconds. At And exactly those 2 times, it was 10 feet off the ground. That's what I was doing. If instead, I set this thing equal to 0, okay, and you solve the quadratic equation of that, it's going to be different numbers, totally different numbers. Got it? I'll tell you what your x answers are going to be. One of them is going to be a positive number. The other one is going to be a negative number. What does this positive number represent? We're trying to get a physical picture of what this parabola is doing, what we're doing when we solve the project.
It's
When
one
the
of
ball
the.
drops to the ground.
It's the time at which the ball hits the ground. Got it? The other one's going to be a negative answer. Is there such thing as negative time? No. And this is the part where I don't think any math teacher will ever tell you this. And this is kind of a physics thing, and I don't even think physics teachers, really think about this. A lot of times people tell you, "Oh, just throw the negative time away. You don't need it. It doesn't make any sense." Because time can never be negative, right? So we just usually just throw this answer out. But really, what it actually does represent is it's saying the ball started off the ground at
At
2 feet already. It started off 2 feet off the ground. And what you were asking me is, when is the ball on the ground? Well, the ball is only on the ground over here because over here it was started off 2 feet above the ground in the first place. Does that make sense?
Yeah,
Yeah.
so there, that kind of helps you measure the angle at which it flew off.
No, not really. This point right here, what it tells you is it says, and this is really just for your analysis, but it tells you if the ball were to be hit from the ground, that's the time at which you would have had to start at in order to be, if this parabola were to continue on, not just start from here and go all the way. I know it's weird talking about negative time to you students, and maybe this is actually a little bit advanced for you, but I think that's kind of makes sense.
Bianca says, so the ball starts when it hits the x-axis, the y-axis.
So apparently in this motion, let's pretend that this was a part of a word problem, and the word problem was a batter hits the ball, at the thing. At what height did the ball start at?
The line.
It would be the y-intercept. Because it starts at time 0. So you plug in 0 and you get 2. That's it. And then if I ask the question like, at what times is the ball 10 feet off the ground?
You would make time.
Then you set this equal to 10, because that's your y value. And you solve it out.
solve for the time that corresponds to that.
Is everyone happy with this?
Yeah.
This is not actually that bad. Plugging in quadratic equations is really all about just identifying your A, B, and C and plugging it into the equation and making sure you don't screw up the calculator.
Yeah, I think most of math, the reason it gets hard is because people come to a conclusion before they even get to the beginning of something. Like they
I agree.
see that they
I
have
do
to
that
do
a
work.
lot.
Yeah, and then they're like, it's
Question.
hard. Impossible.
So
Can I erase, by the way?
Yeah.
Yeah.
when you put the equation to 10 at first and then you subtract the 10, were the ending answers like 0.13 and 0.61 and stuff, or is it corresponds to when the ball hit the ground?
Yes. Well, for the problem I just solved, the 0.13 and the 3.61, those two answers, that corresponds to when the ball was 10 feet off the ground.
Yeah.
But if I didn't have it equal to 10, but instead I had it equal to 0,
It would be
then I would say that's when the ball hit the ground.
Yeah.
Does that make sense? Okay. I think I'm going to show you some physics equations. And you guys are going to look at these physics equations and be like, oh my goodness, that's so crazy, I don't even want to study physics. Calm down. There's a physics equation, write this down, that says delta x
Oh, I see.
equals v naught t plus 1/2 at squared. Got it? This is probably one of the most important physics equations you're going to do in the first 3 months of your physics class that you take, if you take it in college, or you take it from me, or take it in, well, if you take it in high school, you'll be taking it from me. If you take it in college, if you want to be an engineer, this is probably going to govern your life for at least 3 months. This equation right here, delta x equals v naught t plus 1/2 at squared. Let me show you how I'm going to mess with it just a little bit. Ready? And now, if you want, I can show you where it comes from. It's actually not that bad. But I think that would be deviating too much from this lesson on quadratics. This is talking about the x direction. In our case, I'm going to call it the y direction. That's all right with you. So I'm just saying delta y instead of delta x. We cool with that? Let's see. If it's all right with you, I'm just going to take this delta y and move it over to that side. So I have 0 equals v naught t plus 1/2 at squared minus delta y. And delta y is usually known as h, because I'm talking about the height.
If it's change in height, then would it be like, would it be something like the slope formula with h2 minus h1?
Yeah. It's the change, and so it's your change in height.
Okay.
What you're saying is this delta y really means the final height minus the initial height. We talked about the delta before, I think.
Yeah.
Right? So it's h final minus h initial. But let's pretend that all h initials are 0. So if all h initials are 0, then it's just basically h final. So, and if it's all just h final, I'm just going to drop the f because there's only one h. All right. The only other thing I'm going to do, I'm going to switch this around. 1/2 at squared plus v naught t minus h equals 0. Does this look familiar to you?
Yeah.
Oh,
That's like ax squared.
This is the
Yeah.
ax squared, but instead of x's we have t's.
Yeah.
Bx plus c equals 0. This literally is the equation for this motion. You take anything, you throw it up in the air. That's the equation that it follows. The height, as a function of time, will follow this equation right here. The only other part that might be confusing to you is that this a is not the same as that a. So if it's right with you, I'm going to change that to a g. Why do you think I'm calling it g?
Because it's part of the actual a term on the quadratic equation, but it's not the.
It's a very deep answer that's wrong. Why do you think? What? Because can? That's why? No, there's a reason. There's a point.
Gummy bears. So why are you calling it gummy bear?
Because it's the gummy bear
is it
variable.
gravity?
There we go. Because when I'm talking about the acceleration in the vertical direction, what's the acceleration in the vertical direction?
The direction of
Gravity. That's why it's a g. That's for gravity. This is an actual physics equation, and really all it is the standard form of a quadratic equation. It's a standard form of a parabola. Boom, done. Although you don't usually see this. In every math problem, we always tell you, oh, the equation is going to be negative 16 t squared plus 58t plus 2 equals 0 or something like that. I think this is actually straight out of your homework, right?
Yeah.
See this negative 16? You want to know why it's negative 16? It's because if you look up, the acceleration, or not look up, literally.
I did it too. Don't
I
worry.
did it too.
4 of you did it, literally. I thought it was hilarious. No, if you look up the acceleration of gravity in feet per second squared, it's 32. If you go look it up, do gravity in feet per second squared, and it's 32 feet per second squared. That's gravity. And what's half of gravity? 16.
I partially follow.
And it's negative.
Why do you think it's negative?
It's going down.
Because gravity points down. That's why it's negative. That's why every single math problem you're going to see a negative 16 out in front. Or you'll see this, negative 4.9. This is just a totally different problem that I just made up. Would you like to know why it's 4.9?
Yeah.
Because if you look up gravity in meters per second squared, it's 9.8 meters per second squared.
I got
Half of 9.8 is 4.9.
for that problem you gave us in the performance task thing, one of my answers for A was something around 4.9. I should probably round it up to 4.9, but it's not there.
Oh, this relates to the performance task. I didn't know that.
Yeah, so that
But I mean,
makes me feel like I got it right.
the thing that bugs me is in math, we always tell you this. This is the equation. And we never tell you where it comes from. And it really comes from this in physics. That's where it comes from. And see, you know my pet peeve. I hate it when people memorize that, right? Or use this equation. Where did that come from? Where did we get that? Well, we got this negative 16 from gravity, which happens to be, we happen to be using an American version of gravity, which is 32 feet per second squared. The rest of the world uses 9.8 meters per second squared. So that's the equation. That's the number we use in front of that. You know, Americans are backwards in terms of measuring things. We knew that from the beginning of time.
America's
All right. See this number right here? What do you think that represents? That's this one, right? That is the speed at which I threw this thing at in the first place. So apparently, if I threw it like this, then it would have gone up at 58 feet per second. Whereas this one is 10 meters per second. You know what I mean? This is just using a different measuring system. So by looking at these two numbers, if I'm on a math test and they're saying, oh, negative 16 t squared, the equation that governs this is negative 16 t squared plus 58t plus 2, then I would say, this is gravity, and apparently we're doing the American dumb version, which is in feet. This is your speed at which you threw it at, in feet per second. This is how many feet off the floor it started off to begin with. Do you see how these equations relate back to your physical lives that you can see in the real world? I think I love how that works. This tells me, oh, hey, we're using the very smart scientific form. So we're dealing with 9.8 meters per second squared, which is the acceleration of gravity, and half of that is 4.9. This is your speed, this is the height, this is how many meters off the ground it started off to begin with. You guys see it?
Yeah.
All right. Other tricks, other cool things about the quadratic equation. Check this out. What Sophia wanted to know is she wanted to know how do we know? Is there a quick test we can do in order to figure out if I could have factored this in the first place? I don't know if this is a quicker version, a quicker test, but you'll see it and you'll be like, oh, okay, hey, this makes sense to me. I'm going to try to make up a problem off the top of my head. Let's go x squared, and that's always dangerous, x squared minus 6x plus, let's see, 8. Yeah, 8. Okay. use the quadratic equation. Okay? It's negative, or what is b? Negative 6. So negative b is what? So 6 plus or minus the square root. What is negative 6 squared? 36. 36 minus 4 times 1 times 8.
Is the speaker acting up?
Gosh, I don't know what to do to help you out with the speaker. I'm recording this, so I'll make sure to put it up, I promise. I'm sorry.
Maybe X out.
All right. Divided by 2, because 2 times 1 is 2. Got it? 4 times 8. Anyone got that in their head?
32.
What is that?
Negative 32.
Negative 32. Well, it's 32, and then you have that negative there. So you have 6 plus or minus the square root of 36 minus 32, 4. Okay, good. All over 2. 4 is a nice number to take the square root of. I'm happy about that.
Yeah.
This is 6 plus or minus 2 all over 2. So this is really 8 over 2 or 4 over 2. 6 plus 2 is 8 over 2. 6 minus 2 is 4 over 2. That's why I have those numbers. Got it? This is 4, and that is 2. So your x-intercepts are at x equals 4 or x equals 2. And if I were to write that in factored form, it would look like x minus 4, x minus 2. Right?
Yes.
I just used the quadratic equation, blah, blah, blah. The funny part is I chose the numbers so that they would have been nice numbers. So if we had this problem to begin with, we could have just factored it and go straight from here to here.
Bradley's asking what happens to 8 in the square root.
The 8 inside the square root? Oh, it's 36 minus 4 times 1 times 8. 4 times 1 times 8 is 32. 36 minus 32 is 4. That's where that comes from. So yeah, you're right. It's still there. I didn't forget it. Don't worry. All right. Well, we could have factored this to begin with, right? What governs? What did you notice that was different about this problem in the quadratic equation? Because this one we can factor. The other one we couldn't. The first one I did, couldn't factor. That one was too complicated to do. What do you think?
Basically, if you can't just kind of look at it and think off the top of your head.
No, that's not it. There's a very specific test. Notice how we had the nice square root to deal with. If this number becomes a nice square root that we can deal with, then we could have factored it to begin with. So that would be a good check. Like, for example, let's make up another one.
And then, like, if you had to choose between completing the square and using the quadratic formula, you could just choose either one.
I would use the quadratic equation instead of completing the square, personally. However, if they asked me to put something in vertex form, then I would do complete the square.
Okay.
Okay? That's really the only good advantage for completing the square, is to get it from any form you want to vertex form. But I needed the tools from complete the square to give you the quadratic equation. If not, then the quadratic equation would have become, throw it up on the board. Right? It would have just been something I just showed you and did, right? But now I showed you where it comes from. I made sure that you understood it's not magic. It is, all it is just, it's a complicated version of completing the square that I did all the work for you, and you just get to reap the benefits and use the equation. Memorize the story, use the equation. Got it? There's some other thing I want to show you. Let's try this one. X squared minus 10x, let's see, 5.
Bradley says you have a 6.
Oh, 5, hold on. 5 and 15 is 75. I think this might work. Is it plus 75? Oh no, minus 75. Let's see if that works. Okay. So, can I factor that? I don't know. I'll be honest with you, I made this problem up off the top of my head. I don't know if the numbers come out nicely. But let's check it. Let's see if we can use our calculators and check it. I told you that this thing right here, kind of, if that comes out to be a nice square root, then I could have factored it in the first place, right? Well, let's check what b squared is. What's b squared? 100. Got it? Minus 4 times 1 times negative 75. I was a little worried there because I was thinking, wait, 4 times 75 is bigger than 100. I'm going to get a negative number in here. But no, that's not it. Because this is negative 4 times negative 75. So what's 4 times 75? Anyone? If I have 12 quarters, how much money do I have?
$3.
$3, right?
Yeah.
So this is 300. So 100 plus 300, right? It's 400. Hey, 400 is a nice thing to square root, right?
Yeah.
20.
It's 20. So I could have gone back and I could have factored this. Because this thing right here, which I think we call, I forgot what we call it. I think we call the it starts with a Q or a D. I can't remember. But there's a name for this thing inside of here. And here, let me try factoring it. This would be a plus and a minus, and this would be a 15 and a 5. Because 15 times 5 is 75. Negative 15 plus 5 is negative 10.
Yeah.
Papa. Cool?
Very, yeah.
I could have used the quadratic equation. And you want to know what the quadratic equation would have told me? Quadratic equation would have told me x is equal to negative 5 or x is equal to positive 15. That's what the quadratic equation would have told me. Factoring tells me actually the same answer. It's just that's what you set this thing equal to
It's
0.
called a discriminant.
What is that?
Discriminant.
Discriminant, that's what it's called. It's called a discriminant. Think of discrimination. I don't know why I think of discrimination, but it's called the discriminant. This thing inside here is called the discriminant. Got it? How much time do I got?
4 minutes.
5 minutes. All right, one more thing I want to talk to you. If the discriminant is 0, what does that mean?
There are no answers.
No, that's not true.
Square root of 0.
If the discriminant is 0, what does that mean? Okay, so if the discriminant is 0, you're telling me that the x-intercept is at negative b over 2a, right? Well, it would be negative b plus or minus 0 over 2a. So it's really just negative b over 2a.
Oh.
Okay.
What is that saying? Think of what that graph would look like. There's only one x-intercept.
It just hits the.
That means this
Yeah.
parabola comes down like
Yeah.
this,
Oh.
That's cool.
right?
Well,
In order for this thing to touch only once, I can't have a plus or minus whatever on there.
Bradley's asking why we get two
Oh. That's
Oh,
the question.
in this case, you wouldn't get two different answers.
Yeah.
Oh, for the past question. Oh, okay. I think the question was x squared minus 10x plus 75.
No, minus 75.
Minus 75. Bradley, the reason why I'm getting two answers is because apparently this graph, I bet you, if you use a Desmos or whatever and graph this thing, it would look like this. It would go, what did I say the answer was? It was x minus 15 plus 5. So I bet you the graph would look like this. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 15 And it would look something like that. And all the way down here at negative 75, it would cross the y-axis. It would be way down there and then come back up. I bet you that that's what the graph is going to look like. And the reason why you get two answers
You got it right.
is because it crosses the x-axis 2 times. But if the determinant was 0, then it would have only crossed the x-axis 1 time. I can give you an example off the top of my head of something that has a determinant of 0. And you folks are probably even familiar with these types of equations. X squared minus 16x plus 64. Calculate out the determinant of that. All right? Try it. I bet you it's going to be 0. I'll tell you what this graph looks like. That graph looks like that.
Well,
Wait. Okay, wait. For the past question, you got 5 and negative 15 from factoring and negative 5 and 15 from... Oh, okay. Bradley. When I factored it, I'm going to answer your question. When I Bradley's asking, wait a second, why did you get opposite answers when you did the quadratic equation? I told you that the equation looks like this. And then the quadratic equation, I would have gotten this.
Because the actual x variable in there represents the x-intercepts. It's
Because
not
when I factored it, after I factored it, I'm not done solving it. I need to set it equal to 0, right? And then when I set this equal to 0, I ask you, hey, what are the x-intercepts of this thing right here? And you would tell me negative 5 and positive 15. These are actually the same answers. They're not two different answers. Does that make sense to you, Bradley? By the way, did you calculate out the determinant of this? Was it 0? Yes. You want to know why it's 0? I'll show you why. I'll show you why I know how to graph this thing real quick. Because this was a perfect square.
yeah, the only x-intercept is 8, and
If I set this equal to 0, I would take the square root of both sides and I would have x minus 8 equals plus or minus 0. What's plus or minus 0? Still 0. Then x equals 8. That's the only x-intercepts that I
Yeah,
have.
because even if you expand x minus 8 and x minus 8 times x
Boom.
minus 8, it just...
Done. Yeah. I gotta go. It's class is finishing, but question.
So if there's something like 64, like what is that, a perfect square of that number itself
No.
at the end? Because you
What I did was, in order to make up the problem off the top of my head, I just chose an even number. And then, without showing you this middle step, I did in my head, what is negative 16 divided by 2? Negative 8. Square that, 64. That's how I got that number.
and the y-intercept is all the way over.
Oh, the y-intercept over here happens to be at positive 64. If that's equal to 0, that's positive 64. So apparently this graph crosses at positive 64. I mean, like, what I'm trying to do is show you how to kind of be a beast at math. When you look at an equation, you can gather all of these things. You can just basically look at it and just be like, I want you guys to reach the point where your little brother or your little sister says, I need help graphing this thing's so hard. And you look at it and just be like,
Yeah. Oh,
and you
yeah.
just walk away, right? And then you come back and say, I'm sorry, I was kind of a jerk, and let me explain it to you how I did that. But I mean, yeah, to get the effect, you just kind of act like, and then you just, you drop your pen and you just be like a boss, and then just walk away, right? That's what I used to do. I used to solve out these crazy equations on the chalkboard, and at the very end, I would be like, QE Dizzle.
You'd sign it and you autograph it?
Yeah.
Oh, wow.
QED stands for Quotient Error Demonstrat, which means, and thus it has been shown. Back in the day, I added the Dizzle part as my, by flare. But back in the day, when Greek mathematicians would do these crazy proofs, they would write QED, and it's basically just. Sometimes I would write this. That was the old school way of writing this. Booyah! Done. All right, that's I don't know. I want you guys to get to this point where it's like you can look at equations and just be like, this is that piece of information. This is where that comes from. This is why we have that. This is why I spent all this time telling you stories, telling you the background of where this stuff comes from. I don't want it to just be memorize it. Yes.
So when Bradley said, or whoever said full name, he was referring to a classic.
Oh, Diamond Borges, yeah. Diamond Borges is a super cool name. All right, yeah. I didn't think my name was that cool anyway. So I'm fine with that. All right. Any questions about the quadratic equation? I pretty much showed you everything I know about it. Actually, there's a few more things, tips and tricks that I just feel like I don't have the time to do. But we got to hit chemistry. So thank you for Algebra 2 coming in. Let's stop the recording. We'll start up for chemistry, which we're going to be like 5 minutes late on.